In the last lecture, I explained 4 problems based on static and dynamic systems, and we also obtained few important conclusions after solving those problems. In the first conclusion, we saw the systems causing the time scaling are always dynamic. This means the output of a system, if in any form is having the time scaled version of the input, the system is dynamic in nature. So whenever there is time scaling, the system is going to be dynamic. And we have also seen few examples in which output was equal to xt minus 1 or output was equal to xt plus 1, etc. And in all these cases, the system was dynamic in nature. So we can say that whenever there is time shifting involved, the system is dynamic in nature. So we can combine these two conclusions together. Whenever there is an output and it is dependent on the time scaled or time shifted version of input, then the system is dynamic in nature. There is no need to check anything further. You can directly write down the system as dynamic system. The third conclusion was for integration. Whenever we have the integration based system, it is going to be dynamic. The integration based systems are always dynamic. Now let's begin with the problems in this lecture. The 7th problem. In this problem, yt is equal to real part of signal xt. Let's see how we can find out the nature of the system producing this relationship. First, we will assume xt as a plus ib. It is a complex signal having the real part equal to a and the imaginary part equal to b, and we want the real part of signal xt. This means we want a because a is the real part of signal xt, and once we have a, we can easily comment about the nature of the system. And to find out a, I will first find out the complex conjugate of signal xt, and to find out complex conjugate, we only need to change this sign here. We only need to change the sign of the imaginary part. So we have a minus ib. Let's say this is first equation and this is second equation. Now I will add first and second equations. This will give me xt plus x conjugate t equal to twice of a, and from here we have a equal to xt plus x conjugate of t divided by 2, and this is the real part of signal xt, the real part of signal xt, or we can say it is the output of the system. And if you put t equal to 0, t equal to minus 1, t equal to 1 or any other value, you will find the output is always dependent on the present inputs. xt here is the present input and x conjugate t is also present input. For example, when t is equal to minus 1, you will have y minus 1, xt will become x minus 1, and x conjugate t will become x conjugate minus 1. So all these three values are for t equal to minus 1. This means the output at t equal to minus 1 is dependent on the input xt at t equal to minus 1 and also x conjugate of t at t equal to minus 1. So the two values are present values. So this is all for problem number 7. Let's move to problem number 8. In problem number 8, signal yt is equal to even component of signal xt, and we already know the even component of signal xt is equal to xt plus x minus t divided by 2, and the first term here, the first term xt is always going to be present input for the output yt, and the second term x minus t, this will be past input when t is greater than 0, when t is positive, and this will become future input when t is less than 0, when t is negative. So we can clearly see the output yt is dependent on the present input as well as past and future inputs. Therefore, the system is going to be dynamic system. The system is going to be dynamic system, and in this case, in problem number 7, the system was static system. So I hope you now understand how to find out if the system is static or dynamic for the real part of a signal and for the even component of a signal. Now let's move to the problem number 9. In problem number 9, yt, the output, is equal to x t cube. Let's take t equal to 0 for this. Y0 will be x0, but we will check for other values also. T equal to 1, y1 is equal to x1. Till now this is showing the property of a static system, but I will take t equal to 2, and now you will see y2 is equal to x8. 2 raised to power 3 is equal to 8. So the present output is dependent on the future values of input. Therefore, the system is going to be dynamic in nature. The system is dynamic in nature. And regarding this problem, you can keep one thing in your mind. Whenever there is any operator on time, this is operator here, this is operator here. So whenever there is any operator on time, the system is going to be dynamic. You can use this result directly while solving the questions. Now we will solve the 10th problem. The 10th problem is the last problem in this lecture, and after this I will give you homework problems. There are 4 homework problems in this lecture. In the 10th problem, yt is equal to d by dt of xt. This means yt is the first derivative of signal xt, and the first derivative gives us slope. So we are calculating the slope of signal xt with respect to t, and it is equal to output yt. And to calculate the slope, we need 2 different points. For example, if we have a straight line like this, then to find out the equation of a straight line or to find out the slope, we need 2 points. For example, this point and this point is required to find out the slope of the line, and it is very much clear that we cannot calculate the slope only with the present value, because we need one past or one future value. In that way only we will have 2 different points, and by the help of 2 different points we can calculate the slope. For example, if this is present time, then we need at least one future value or at least one past value. In that way only we can calculate the slope. So I think this point is clear to you that the systems which are based on differentiation are dynamic in nature. Dynamic in nature. Now let's move to the homework problems. In the first homework problem, output yt is equal to x under root t. In the second problem, output yt is equal to imaginary part of signal xt. In the third problem, output yt is equal to integration of x tau d tau from t minus 4 to t plus 4. And in the last problem, in the fourth problem, d by dt of yt plus 3yt is equal to 2xt. So these are the 4 problems, and once you have your answer, post it in comment section. You need to find out if the systems giving us these relationships are dynamic or static. And once you have your answer, post it in comment section. I will end this lecture here. See you in the next one.